guys, and welcome back to Aisha.Academy. And in today's video, we're going to be going through laws of logarithms. So let's get right into it. So when it comes to your logarithms, right, this is like your main GOAT formula for logarithms, and it's really important for you to understand this main formula. And that is that if you have a to the power of x is equal to b, per se, if you're writing this in the form of logs, you're going to write it as log base a b is equal to x, and it is very important for you to familiarize yourself with this formula and to understand it. However, other than this main formula, you do have different laws of logarithms which you do need to know, because unfortunately they do not give them in the formula booklets. So the first one is that if you have log base a xy, that would be equal to log base a x plus log base a y. And in terms of indices, this relates to a to the power of x multiplied by a to the power of y being equal to a to the power of x plus y. The second one is that if you have log base a x over y, this could be written as log base a x minus log base a y. And how I remember this is because in the first one, they're multiplying each other. And I think of it as your multiply sign, if you flip it around a bit, it's actually similar shape to a plus sign, whereas the other one, they're dividing each other. And notice how I've put the division in the form of a fraction, and that line of the fraction is kind of like your minus sign. So that's how I remember to distinguish between the two. And in terms of laws of indices, this relates to a to the power of x divided by a to the power of y being equal to a to the power of x minus y. So it's very important for you to refresh your memory on your laws of indices when it comes to logarithms, because either or could be interchangeable in an exam question. So you need to familiarize with that yourself with that. The last one is that you have log base a x to the power of k. So that power is going to come in front. So you're going to have k log base a x. And again, in terms of indices laws, this relates to a to the power of x to the power of y, so all of that to the power of y, and that's equal to a to the power of x times y. So it's important to note that all these laws are useful when a is greater than 0 but not equal to 0. So other results to familiarize yourself with, just to save time in an exam. So the first one is that if you have log base a, that is equal to 1. So if your base and the number next to it are the same, it's equal to 1. The second one is that if you have log base a to the power of x, that is equal to x. And there's two ways to think of it. One, we just saw that log base a is equal to 1. So 1 to the power of x is, so it's just going to be 1. So then that's going to cancel out. So it's going to leave you with x. Another way to think of it is that if you have log base a to the x, that could be rewritten as x log a, as we just discussed in the different laws of indices. And we know that that's x, because again, the whole log base a is equal to 1, so cancel out. Third one is that if you have a to the power of log base a x, that is also equal to x, because a to the power of the log of its same base will cancel out. Rule number 4 is that if you have log base a1, that is equal to 1, because if we rearrange that using the main formula I mentioned first, this would be rearranged to a to the power of 0, and anything to the power of 0 is equal to 1. The fifth one is that if we have log base a 1 over x, this could be rewritten as log base a1 minus log base a x. And again, this is very similar to the second laws of logarithms I just mentioned previously. And so because we know that log base a1 is 0, that's going to cancel out. And so it's going to leave us with minus log base a x And the last one, number 6, right, is all to do with the different logarithms to do with exponentials, but I'm going to do a full video on exponentials if you don't understand it now, so don't worry too much about it. The first one is that if you have log base e exponential x, that is equal to natural log. The second one is that if you have ln natural log e to the power of x, that is the same as saying x. This relates to example 2 I just explained in the results. And if you have e to the power of ln x, that's equal to x, which relates to result 3 that I was talking about previously. So an example question, if you have log base 3, 27, and it wants you to work out the value, we are going to use the main formula that I mentioned initially to do that. So we're going to rearrange this to 3 to the power of x is equal to 27. And knowing your indices laws, you would know that 3 cubed is equal to 27, so therefore x must be equal to 3. So now we're going to go into some practice questions to understand this further. Example 1. So here it wants us to evaluate this logarithm equation, and so to do that we're basically going to work out each of the numerical values of each logarithm and then put them back into the equation to work out the value. So the first one, we've got log base 2, 4, that would be equal to x. So if we rearrange this, this would be 2 to the power of x is equal to 4. We know that 2 squared is equal to 4, so therefore x is equal to 2. For the second one, it's actually the same as the worked example I just explained earlier. So again, log base 327 equal to x, rearrange to 3 to the power of x is equal to 27, so therefore x is equal to 3. And then for the last one, we've got log base 4, and then we've got 4. And if that's equal to x, that would rearrange to 4 to the power of x is equal to 4. And anything to the power of 1 is itself, so therefore x is equal to 1. So now putting these numbers back in, we would end up with 2 plus 3 minus 1. 2 plus 3 is 5, minus 1 is 4. And that's your final answer. So example 2. So here it wants us to solve this equation, and it wants us to actually write it in the form of logarithms, okay? So the first thing that we're going to do is we're going to rearrange that 5 to the power of 2x based on the indices law I mentioned previously. And this would change to 5 to the power of x squared. And then we're going to leave the minus 8 times the 5 to the power of x plus 12 equals 0 the same. The reason why I've rearranged it is because you've already got 5 to the power of x in the equation, and it's going to make it easier to change things up. We're now going to bring y involved. Why? Because by bringing y involved, it's going to be easier for us to factorize this and solve for values. So we're going to substitute 5 to the power of x with y. That would leave us with y squared minus 8y plus 12 equals 0. We're now going to use our knowledge of factorizing quadratics to solve and factorize this equation. So that would leave us with, in one bracket, y minus 6, and in the other bracket, it would leave us with y minus 2. Now that we know our brackets, this would now mean that our two y values are y is 6 and y is 2. Substitute back in the 5 to the power of x, so therefore 5 to the power of x is equal to 6, and 5 to the power of x is equal to 2. And again, using the main logarithm formula, as mentioned before, this would change to log base 5, 6 is equal to x, and log base 5, 2 is equal to x. So I hope that was really useful. My main advice for logarithms is really and truly you need to practice all the logarithm questions you can find. I'll put some links in the description below of different exam resources, questions that I personally would recommend. But you need to practice to get used to knowing which law you're going to use in that question, etc. But I hope that was really useful. Thanks for watching. Please comment, like, and subscribe and share, and stay tuned for more content.